And tell me, among hydrocarbons, among organic compounds, alkanes are the most stable organic compounds. Why? Because of carbon-carbon single bond. They are saturated, they have carbon-carbon single bond. So carbon-carbon single bond has more strength compared to double bond and triple bond. Double bond can be broken easily compared to single bond, right? Single bond has more strength and it cannot be broken so easily. Therefore, alkanes are more stable compared to alkene and alkyne. Okay. Therefore, in general, alkanes are chemically inert. But even though they are chemically inert, alkanes can undergo substitution reaction in presence of sunlight and high temperature. That is free radical substitution reaction. Therefore, so we are studying substitution reaction now. So tomorrow class we will continue that substitution. In substitution reaction there are 3 substitution. 1 electrophilic, 2 nucleophilic, 3 free radical. Therefore, substitution reactions are 3 types: electrophilic, nucleophilic, free radical. Which organic compounds can undergo electrophilic substitution? That is addition reaction, man. Alkene and alkyne can undergo electrophilic addition. This is substitution. So which organic compounds can undergo electrophilic substitution? Benzene and its derivatives. Benzene and derivatives, right? Benzene and their derivatives can undergo electrophilic substitution. Nucleophilic substitution, SN1, SN2, where we study haloalkanes, haloarenes, haloalkanes, and free radical is alkane. It means substitution is 3 types: electrophilic, nucleophilic, free radical. Then electrophilic substitution is, it is a property of benzene and derivatives. Benzene and derivatives undergo electrophilic substitution, and haloalkanes undergo nucleophilic substitution. Free radical is alkane. Alkane undergo free radical substitution reaction. Therefore, so here in chemical properties of alkane, alkane undergo free radical, alkanes undergo free radical substitution reactions, right? So therefore, alkanes can undergo free radical substitution reaction in presence of remember helper. So free radical reactions are usually takes place in presence of heat, electricity, light, peroxide and radicals. Helper. Okay. Then what are the chemical properties of alkane? 1 halogenation, 2 nitration, 3 sulfonation, 4 oxidation. In oxidation there are 3 oxidation: A complete oxidation, B incomplete oxidation, C controlled oxidation. Or catalytic oxidation. 5 isomerization, 6 aromatization, 7 pyrolysis, cracking. Okay. See, among this only important is this, other are just equations. we can expect some important questions on halogenation. Okay, tell me. First one, halogenation of alkane. This halogenation of alkane we will study even where preparation of haloalkanes. Yes or no? Okay. So what is halogenation of alkane? Alkanes reacts with halogen in presence of diffused sunlight or even heating also. In presence of diffused sunlight to form corresponding haloalkanes. It means methane. Alkanes reacts with halogen, let us take X2, in presence of diffused sunlight H nu. And tell me, one hydrogen 1x, methyl X plus HX will be formed. This is a free radical substitution reaction. It is a free radical substitution reaction. Okay, can you tell me what is the meaning of free radical substitution reaction? The substitution reaction which is initiated by free radical. If the substitution reaction initiated by the free radical is called free radical substitution reaction. Okay, then but we know that free radical substitution reaction takes place in 3 steps, right? How many steps? So it takes place in 3 steps. 1, chain, initiation. Tell me, in chain initiation, let us take X2. It is in presence of H nu. It undergo homolytic cleavage. What it form? X dot plus X dot. You will get the X free radical. So therefore, halogen undergo homolytic cleavage in presence of sunlight. They form halogen free radical. This is a chain initiation. Next, step 2. Chain propagation. Tell me, in chain propagation, let us take methane CH3 H CH4. This methane reacts with the halogen free radical. In methane, this carbon hydrogen undergo homolytic cleavage. This homolytic cleavage with half-headed fish hook arrow, right? So therefore, what happened? Now methyl radical, X radical, you will get CH3X plus X radical plus H radical. Okay, so this is a chain propagation. Next what happened? Next, there is a hydrogen free radical. Next is hydrogen free radical. It is reacts with what? X free radical. What it form? HX. Okay, next is step 3. Chain termination. Come on, tell me. In chain termination, what happens? In chain termination, the reaction will stop now. How reaction will stop? Reaction will stop by combining the free radical. Okay, in first step, halogen free radical formed. This halogen free radical, one second, something wrong. No, here. Wait. Now here it undergo homolytic cleavage. You will get a methyl radical plus HX. Now next is methyl radical. It reacts with X2. One more halogen. Now this is undergo homolytic cleavage. Methyl radical X radical methyl X plus X radical. Okay. Now next is chain termination. In chain termination, so all the free radical combined. In first step X radical, second step methyl radical, X radical. Now what happened? There may be a methyl radical plus X radical, it combines CH3X. There may be a 2 methyl radical combined, methyl radical plus methyl radical. There may be a ethane may be formed. Next there may be a X radical also combined. It means all possibilities. So therefore in chain termination all the radicals combined, because there are X radical, methyl radical, X radical. So what are the 3 possibilities? Methyl X radical combined, methyl combined, X combined. Therefore if any one of this reaction takes place, reaction will stop. Okay, that means this is chain termination. Therefore free radical substitution takes place in 3 steps: chain initiation, chain propagation, chain termination. Okay, next. Now tell me, what is the order of reactivity? Reactivity of halogen. So in this reaction, what is the order of reactivity of halogen? So which halogen is more reactive? In last class we have studied halogen acid. In halogen acid HI is more reactive, yes or no? HI is more reactive, but here is fluorine is more reactive than chlorine, then bromine, then iodine. Therefore fluorine is more reactive towards free radical substitution reaction. Okay, so therefore here fluorine is a most reactive towards this reaction, iodine is least reactive towards this reaction. Okay, next point. Then what is the order of reactivity of hydrogen? Which hydrogen is more reactive? Tertiary hydrogen more reactive than secondary hydrogen, then primary hydrogen. Okay, so this is the order of reactivity of hydrogen. Okay, so tertiary hydrogen more reactive because you will get tertiary free radical. Tertiary free radical is more stable, no? Tertiary hydrogen is more reactive because tertiary hydrogen reacts, it forms tertiary free radical which is more stable, right? So therefore tertiary hydrogen, then secondary, then primary hydrogen is more reactive. Okay, now tell me, in halogen fluorine more reactive, in hydrogen tertiary hydrogen is more reactive. So since fluorine is more reactive, iodine is least reactive. By this method 2 haloalkane cannot be prepared. Which 2 haloalkanes? Which 2 haloalkanes cannot be prepared by this method? 1 fluoroalkane. You cannot prepare fluoroalkane directly by using this method because the fluorination of alkene is a highly exothermic reaction. Since fluorine is a most powerful oxidizing agent, most reactive, and it has highest SRP value and highest enthalpy of hydration. So therefore fluorine is a more reactive. That's what the fluorination of alkane is not possible. No, it is not possible. It is highly exothermic. If you try to prepare fluoromethane or any fluoroalkane, that may be the last reaction. That is last agbodu, because this reaction is a explosive, right? Therefore fluoroalkanes cannot be prepared by this method. And one more difficulty is iodoalkane. Iodine is the least reactive. You can prepare it, but you have to wait for who knows, days, months, years. It is a very, very slow reaction and reversible reaction. Even it is a slow reaction, no problem, but reversible. Whatever the reactant converts into product and converts into reactant. Again ಮಾಡ್ತೀರಿ ನೋಡ್ತಿರ್ಬೇಕಷ್ಟೇ, right? So therefore Now due to these two practical problems, so fluoroalkane, iodoalkanes cannot be prepared by this method directly. Okay, but we have indirect method to prepare the fluoroalkane, iodoalkane. Tell me, what are the indirect methods to prepare fluoroalkane, iodoalkane? There is a method called Finkelstein reaction, Schwarz reaction, right? Schwarz and Finkelstein. Tell me, what is a Schwarz reaction? Schwarz reaction, and one more is Finkelstein reaction. Tell me, see here, Finkelstein reaction starts with F, but it is not used to prepare fluoroalkane. It is used to prepare iodoalkane, opposite. So therefore, Finkelstein reaction is, you can take either chloroalkane or bromoalkane, because chloroalkane, bromoalkane can be prepared. Chlorine and bromine is, of course, not very much reactive, not very much, even slow also. So chloroalkane, bromoalkane reacts with sodium iodide. Sodium iodide, it is in presence of dry acetone. Okay, then what can be removed? NaBr, NaCl will get corresponding iodoalkane. Therefore, this is the indirect method to prepare iodoalkane. So instead of that, can you do like this? Take the methane plus iodine gives rise to methyl iodide, is possible? No, it is a reversible reaction. No, you will get it methyl iodide. You will get methyl iodide plus again HI. But we know that hydroiodic acid is more reactive. Yes or no? HI is more reactive. This HI is more reactive. It reacts with this. Again, it forms this. Hence, it is a reversible reaction. Since it is a reversible reaction, so you cannot get the product much. Once the product formed, product converted into reactant. We want actually product. That's what we go for this method, Finkelstein reaction. By using Finkelstein reaction, it is an indirect method. How? Prepare the chloroalkane, bromoalkane. From chloroalkane, bromoalkane, then treated with sodium iodide, you will get iodoalkane. Then there is a Schwarz reaction. This Schwarz reaction is used to prepare fluoroalkane. How? It is again same. Let us take chloroalkane, bromoalkane. So chloroalkane, bromoalkane can be prepared so easily by this method. Yes or no? Then now chloroalkane, bromoalkane treated with metallic fluorides. You can take any metallic fluoride like silver fluoride, mercury fluoride, cobalt fluoride. Okay, I have taken silver fluoride. Instead of silver fluoride, you can take cobalt as well as even mercury also. Metallic fluorides, tell me what can be removed here? AgCl, AgBr, then you will get RF. So this is the easiest method, safest method to prepare the fluoroalkane. So instead of that, if you do this methane plus fluorine HF2, you will get the fluoroalkane HF, but the fluoroalkane. But amel naviralla. Okay, so therefore this is highly exothermic reaction. This is highly endothermic. ಆ ಥರ ಹೇಳಿಲ್ಲ ನಾನು, ನೀವು ಇಮೇಜ್ ಮಾಡಿಕೊಂಡ್ರೆ slow reaction and so it is a slow and reversible reaction, right? Okay, so therefore these two are the limitations of this halogenation. But anyhow, this fluoroalkane highly exothermic, we should not touch it. Bedadu adar bagi beda. Then somehow we can do this, you can make it reversible to irreversible. That is possible. So therefore now what we do is, it is a slow reaction, reversible reaction. Tell me, It is slow is no problem, but problem is reversible reaction. Why this is reversible reaction? HI is more reactive. In this reaction HI is formed. This HI is more reactive compared to this I2. Newly F2 more reactive than F2 more reactive. In HI, the HI is more reactive. Therefore, this HI is more reactive compared to I2. That's what, by mixing these two, you will get these two. But immediately, this is reacts with this, you will get this. So therefore, this is reversible reaction. This reversible reaction can be made into irreversible reaction. How? The simple method is, we apply the Lee-Chatelier principle. According to Lee-Chatelier principle, what we do is, to make this irreversible, you remove any one of this product. Okay, either remove this methyl iodide, whatever forming, you make separate it, or else you remove this HI. Suppose if I remove HI, whatever it is forming immediately, is there any possibility of reversible? No. Simple, no? Then problem is, how do you remove? And spatula ತಗೊಂಡು remove ಮಾಡ್ತೀರಾ, spoon ತಗೊಂಡು ಮಾಡ್ತೀರಾ? Right. So therefore, it is not like that. So here every chemical reaction is like, to catch the fish. ಏನು ಯೂಸ್ ಮಾಡ್ತಾರೆ? Hook. And it is hook with some food, no? Bread or something. Here also same. Now to remove this, we add some reagent which has more affinity toward this. That is called oxidizing agent. We mix oxidizing agent. So therefore, by adding oxidizing agent, those oxidizing agent can react with this. It forms some other product, so that it can be removed completely. Then there is no problem. Reversible become irreversible. Therefore, this reaction is carried out by adding what? Oxidizing agent. CH4 plus iodine. Now it is treated with or mixed with either HiO3 or HNO3. These two are the oxidizing agent, and which convert into, of course, methyl iodide plus HNO. So therefore, this reaction is carried out in presence of oxidizing agent. Then what is the function of oxidizing agent? These oxidizing agent can oxidize hydroiodic acid into iodine. It means they remove this. So that means these two can remove this. Suppose if I take HiO3, this HiO3 is added to this mixture. This HiO3 reacts with HI. Okay, so therefore take here 5 moles. Now it is 1 plus 5 iodine. This is 5 iodine plus 1, 6 iodine, 3 I2 plus, tell me, 5 plus 1 hydrogen 6, it means 3 H2O. Therefore here this hydroiodic acid converted into iodine. It means we have removed this product. Then there is no question of reversible. Even now this is called HiO3 is oxidizing agent. So instead of HiO3 you can also take HNO3. HNO3 also reacts with hydroiodic acid, 2 moles, 2 moles. So it converts into, of course, I2 and 2H2O plus 2NO2. So therefore HI can get converted into I2. So in this way, this reaction can be used. Okay. Now let's see some example. Methane plus chlorine in presence of HNO. Ethane plus chlorine, HNO. propane plus chlorine H nu. So write the product. Methane plus chlorine, methyl chloride. It is ethyl chloride. Here tell me. Now in ethane the two carbons are same, that's what you will get one product, but here is what 1 2 3, 1 and 3 carbons are same, second carbon is different, therefore here two products are formed, one chloropropane plus 2 chloropropane. Tell me, among 1 chloropropane, 2 chloropropane, which is major? Why? Order of reactivity of hydrogen. Which hydrogen is more reactive? Secondary hydrogen. Since secondary hydrogen is more reactive, so this hydrogen reacts with chlorine, it forms major. This is minor. Okay. Next, one more. Let us take chlorine. Just write the product. How many products? I want number of product. Here no, this is one, no, this is one. Here is two products. There how many products? Tell me. So how many product will be formed? Huh? 2 or 1? 2. See here we need to identify there are how many different hydrogen. It is methyl, methyl, methyl. All are primary, no? Same or not? So there are 9 hydrogens are same. It means if the chlorine comes here or here or here, it will be same. You will get same IUPAC name. If the chlorine comes on this carbon, you will get another product. Therefore, how many total product? 2. Then which is the major? When chlorine comes on tertiary carbon, because tertiary hydrogen is more reactive. Yes or no? So therefore, here question is number of products. 2 products. Tell me here. Huh? This was actually CT question. It is called neopentane. Neopentane on chlorination gives total number of products. Neopentane on chlorination, it gives only one product, because if the chlorine comes here or here or here or here, you will get same product. Then how to identify same product? You write the IUPAC name. Right, you can try it. You write the chlorine here, write IUPAC name. Write chlorine here, write IUPAC name. You will get same IUPAC name. If you get the same IUPAC name, product will be same, because IUPAC name is a unique name, right? So no two compound having same IUPAC name. No same IUPAC name for two compounds. Idi atara iltane iralla namgant irutte bere bere names irtavalla illandu ನೀವು ಇಡ್ತೀರಿ. So how many? One or not? One product. Next, it is 1 because all the carbons are same on cyclohexane, that is only 1 here. Somebody said 4, very good. 4 because chlorine substitute here 1, chlorine come here, 1, ortho, 2 are same, no? This is meta, same, no? This is para. Yes or no? 1, 2, 3, 4, 5. You said 4, 5. At least ಬೇರೆ ಆನ್ಸರ್ ಇದೆಯಲ್ಲ, ನೀವು ಒಂದೆರಡು ಇದೆ ಅಷ್ಟೇ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನೋಡಿ ಇನ್ನೊಂದು ಒನ್ ಮೋರ್ ಟೈಪ್ ಕ್ವಶನ್ ಇಸ್ ಇನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಸಿ ನೋಡಿ, ಈ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿಯಲ್ಲಿ ಕ್ಲೋರಿನೇಷನ್ ಒಂದೇ ಇರೋದು, ಉಳಿದೆಲ್ಲ ಜಸ್ಟ್ ಈಕ್ವೇಷನ್ ಅಷ್ಟೇ. 10 ನಿಮಿಷದಲ್ಲಿ ಮಾಡಿಬಿಡ್ತೀನಿ, ಇದೇ ಇಂಪಾರ್ಟೆಂಟ್. ನೆಕ್ಸ್ಟ್ ಅನದರ್ ಕ್ವಶನ್ ಈಸ್ identifying the monochloro product or product in monochlorination. So what is the identification of products in monochlorination? Majority questions will be on this chlorination only. That's what we are spending little more time. Okay, it is important. So identification of product in monochlorination. Tell me, first of all, we should understand what is the meaning of monochlorination. Alkane undergo monochlorination, it gives the product. The meaning of monochlorination is only one chlorine has to be substituted. For example, CH2 CH3, it is Cl2 H nu monochlorination. Tell me, it is a propane undergo monochlorination. What is the product? We should write only one product. Which one product? 2-chloro, because now here 1-chloro and 2-chloro possible, but we wanted to write only monochlorination. If there is only one chlorine is there, that one chlorine preferentially substituted on second carbon, because secondary hydrogen is more reactive. So therefore the monochlorination product is isopropyl chloride. That is the meaning of monochlorination. We should write only one product. Similarly, if there is a okay 2-methyl propane monochlorination, you write the product. So write the monochlorination product. Tell me here, what is the monochlorination? Right, tertiary hydrogen replaced by chlorine. Next, because all the hydrogens are same, you will get one product. Next here, tertiary hydrogen, how secondary? So here, ಎಲ್ಲಿ here ಇಲ್ಲಿದೆಯಲ್ಲ ಹೈಡ್ರೋಜನ್, Okay, so identification of monochloro product also important. Next is nitration. Nitration. Tell me. So what is nitration? So nitration is usually higher alkanes, more than 6 carbon. Higher alkanes are heated with concentrated nitric acid, they form corresponding nitroalkanes. Right? So higher alkanes, let us take a C6H14. Okay, it is reacts with the concentrated HNO3. Okay, this concentrated HNO3 can be taken as OH NO2, right? H NO2O NO3. Tell me, one OH, one hydrogen can be removed, C6H13 NO2. It is called nitro alkane. Okay, and but this reaction also possible with smaller hydrocarbons, but high temperature is required. It is at 773 Kelvin temperature. Therefore, smaller hydrocarbon can also undergo nitration. In nitration, again it is same. You can write CH3H plus OHNO2, right? What should be removed? H2O. Then nitromethane is a product, right? Plus H2O plus H2O is nitration. Therefore, what is the nitration of alkane? Alkanes reacts with concentrated nitric acid to form nitroalkanes. That's it. But the condition is higher alkanes room temperature, smaller alkanes at high temperature 773 Kelvin temperature. Even you can take ethane, propane also same temperature. Next is sulfonation. Sulfonation. Tell me, in sulfonation, like similar to nitration, sulfonation also same. Alkanes reacts with concentrated sulfuric acid at high temperature. No, higher alkane at room temperature, they form corresponding sulfonic acid. For example, C6H14. It is a hexane. Hexane reacts with concentrated sulfuric acid H2SO4. Then this can be written OH SO3H. Yes or no? H2 SO3 and O SO4. Then what can be removed? Water, OH and one hydrogen. So therefore C6H13 SO3H, it is a sulfonic acid. So therefore when you take 6 or more than 6 carbon, this reaction takes place room temperature, but at for smaller alkane, concentrated sulfuric acid, this reaction takes place 773 Kelvin. Then here methane, you can write CH3H and this is OH SO3H. So what can be removed? H2O. Then tell me what it forms? CH3 SO3H plus, so this is sulfonic acid, methyl sulfonic acid. Okay, so therefore nitration, sulfonation exactly similar. It is nitroalkane, it is sulfonic acids, corresponding sulfonic acids. That's it. There is no much information, not required also. Next is oxidation. Right, oxidation. In oxidation there are 3 oxidation. One complete, second incomplete, and third one is controlled. First one is a complete oxidation. Tell me, complete oxidation. So what is the meaning of complete oxidation? Combustion? No. Oxidation is nothing but combustion, complete combustion. Okay, so what is complete combustion? See, all organic compounds undergo complete combustion. They form only two products: carbon dioxide, water. Of course, heat. Right? Alkane, alkene, alkyne, alcohol, whatever you take, the final product is in complete combustion. Hydrocarbon convert into carbon dioxide and water. Heat will be liberated. So therefore, here also, for example, if you take alkane, methane plus oxygen, it forms CO2 plus 2H2O. It means you should take 2 moles. Okay, but then to write the balancing equation, there is a one general equation: CXHY plus X plus Y by 4 O2. Okay, gives rise to XCO2 plus Y by 2 H2O. You can balance by this equation, where what is X and what is Y? X equal to number of carbon atoms, Y equal to number of hydrogen atoms. Important, this equation comes in all organic reactions, organic topics. For example, if I take C2H6, tell me, C2H6, where X equal to what? 2, Y equal to 6. Yes or no? Then write the combustion, complete combustion of this reaction, this ethane. C2H6 plus X plus Y by 4, no, 2 plus 6 by 4, O2 gives rise to XCO2, 2CO2 plus 6 by 2 H2O. So what do you get here? This is 5 by 2 O2, right? 7 by 2, 7 by 2. Here 3. So like that you can write the balanced equation. It is complete combustion. It is also called complete oxidation. Next is incomplete combustion or incomplete oxidation. Tell me, if hydrocarbon undergo incomplete oxidation, what is the product? Either may be carbon monoxide or it may be carbon also. Yes or no? Incomplete CO2, incomplete, either may be CO or even carbon. For example, methane undergo incomplete oxidation, combustion, it may form CO plus H2O. Or methane plus oxygen, incomplete oxidation, it may form C plus H2O. You should write balanced equation, that's it. Okay. Next is controlled oxidation. This is important. Controlled oxidation. This controlled oxidation also called catalytic oxidation. Okay. So here methane plus oxygen in presence of copper 573 Kelvin will get methyl alcohol. In same way, methane plus oxygen, it is in presence of molybdenum trioxide or even chromium trioxide, you will get a formaldehyde. So it means both are oxidation. It is in presence of copper 573, it is in presence of molybdenum or chromium. but product are different. Here methyl alcohol, here is formaldehyde. So this is called controlled oxidation, but it is a controlled. So the reactant is same, product are different. This is we study in surface chemistry also. In catalyst we study this particular reaction. Reactant is same, but product are different. It is due to presence of different catalyst. Okay, next there is another reaction. Ethane also undergo oxidation in presence of manganese acetate it form acetic acid. Okay, next one important reaction. It is a isobutane. Isobutane has one tertiary hydrogen. It is reacts with alkaline KMnO4. Important. In presence of alkaline KMnO4, this tertiary hydrogen replaced by OH. You will get the tertiary alcohol. Important. So these are the controlled oxidations. Remember reactant and product reagents. So next is isomerization. Tell me. So what is the meaning of isomerization? One isomer can convert into another isomer. For example, N-butane. Let us take N-butane. N-butane, it is treated with anhydrous AlCl3 and HCl. So anhydrous N-butane reacts with anhydrous AlCl3 HCl, which converts into isobutane. This is N-butane, isobutane. So here important is one isomer can convert into another isomer in presence of this reagent. Here reagent is important. They will give the reactant and product, they expect reagent. They will give the reactant and reagent, expect product. Okay, this is isomerization. Next, aromatization. Aromatization. Tell me, in aromatization what happens? In aromatization, aliphatic hydrocarbon converts into aromatic hydrocarbon. Like for example, take N-hexane. Okay, this is N-hexane. It is aliphatic hydrocarbon. This aliphatic hydrocarbon heated in presence of Al2O3, aluminium oxide, and CrO3, chromium oxide. So therefore N-hexane converts into benzene. Number of carbon same. So therefore aliphatic hydrocarbon converts into aromatic hydrocarbons. It is Cr2O3. Okay, Cr2O3. So next is, last one is, which reaction it is? Pyrolysis. So what is pyrolysis? Pyrolysis, it is also called cracking, no? So pyrolysis, it is higher hydrocarbons like 4, 5, 6 carbon atom having hydrocarbon. Higher hydrocarbons, they are heated in absence of oxygen. So its cracking is nothing but pyrolysis. It is nothing but heating the hydrocarbon in the absence of oxygen. When hydrocarbons are heated in absence of oxygen, higher hydrocarbon get converts into lower hydrocarbon. It is just like, what is it? Extraction of oil. From the crude oil, we will get the different oils around. There is a pyrolysis process takes place, right? So usually crude oil has N-hexane. When N-hexane, it has CS3, CH2, CH2, 4, 5, 1, 2, 3, 4, 5, 6, N-hexane. This N-hexane on subjected to pyrolysis. Tell me, what do you get? This N-hexane undergo breaking. It converts into mixture of small alkanes. Like it may give methane plus ethane, comma, propane. 1, 1, 2, 1, 2, 3, 4, 5, 6. So therefore, a higher hydrocarbon get converts into smaller. Sometime even you will get alkene also. Now what happened? Again heating this. Now this may converts into again alkene, because 2 hydrogen is removed as H2. So therefore, in pyrolysis, higher hydrocarbon on heating, they converts into smaller hydrocarbon. Even unsaturated hydrocarbon also be formed. Okay, it is pyrolysis. So this is about alkanes.